A file allocation table, FAT, is a table that an operating system maintains on a hard disk that provides a map of the clusters, the basic units of logical storage on a hard disk, that a file has been stored in. When you write a new file to a hard disk, the file is stored in one or more clusters that are not necessarily next to each other. They may be rather widely scattered over the disk. A typical cluster size is 2048 bytes, 4096 bytes, or 8192 bytes. The operating system creates a FAT entry for the new file that records where each cluster is located and their sequential order. When you read a file, the operating system reassembles the file from clusters and places it as an entire file where you want to read it. For example, if this is a long web page, it may very well be stored on more than one cluster on your hard disk. Disk allocation methods. A. Contiguous allocation. Each file occupies a set of consecutive addresses on disk. Each directory entry contains file name, starting address of the first block, block address equals sector id, for example, block equals 4K, length in blocks, usual dynamic storage allocation problem. Use first fit, best fit, or worst fit algorithms to manage storage. If the file can increase in size, either leave no extra space, and copy the file elsewhere if it expands. Leave extra space. B. Linked allocation. Each data block contains the block address of the next block in the file. Each directory entry contains file name, block address, pointer to the first block. Sometimes, also have a pointer to the last block. Adding to the end of the file is much faster using this pointer. C. Indexed allocation. Store all pointers together in an index table. The index table is stored in several index blocks. Assume index table has been loaded into main memory. I. All files in one index. Better than linked allocation if we want to seek a particular offset of a file because many links are stored together instead of each one in a separate block. SGG call this organization a linked scheme, but I call it an indexed scheme because an index is kept in main memory. 2. Separate index for each file. One index block per file, assumes index is contiguous. Linked list of index blocks for each file. Multi-level index. Combined scheme, inode scheme, used in Unix. Inode. The inode is a data structure in a Unix-style file system that describes a file system object such as a file or a directory. Each inode stores the attributes and disk block locations of the object's data. File system object attributes may include metadata, times of last change, access, modification, as well as owner and permission data. Directories are lists of names assigned to inodes. A directory contains an entry for itself, its parent, and each of its children.